What you're looking at now is the true surface of Mars. On September 27, 2006, when Opportunity traveled 7 kilometers from its landing site to the rim of a massive crater, the images it sent back took the world by surprise. This was a miracle created by Opportunity and one of the most moving chapters in the history of human exploration of Mars. Opportunity's journey to Victoria Crater is legendary in itself. Designed to last only 3 months, it operated on Mars for 15 years, traversing over 45 kilometers, making it the longest-serving human probe on Mars. Standing on the rim of Victoria Crater, this massive, 730-meter-wide crater was the largest Opportunity had encountered to that point. But what made it special was that its 70-meter-deep crater meant that the exposed rock layers on the crater's walls were even older. Just like how we study ancient strata on Earth by digging deep wells, the natural cross-section of Victoria Crater is this. Opportunity provides an exceptional window into Mars' distant past, searching for evidence of water. Engineers even upgraded Opportunity's core and uploaded new software for this exploration. After the update, Opportunity can independently decide which images to take, which rocks to extend its robotic arm to sample, and even plan safe routes around obstacles, saving significant time. Because communication delays between Earth and Mars can be up to 40 minutes, ground control cannot monitor the situation in real time. As Opportunity drove along the crater's edge, it surveyed several spectacular cliffs in detail. It used a clever technique called super-resolution stitching to capture these cliffs. Simply put, multiple slightly offset images of the same target are taken sequentially. Then, through complex post-processing on Earth, these images are stitched together into a single, high-definition image with a resolution far exceeding the camera's native capabilities. These high-resolution images reveal a clearly visible, alternating layer structure within the cliff walls. Scientists have determined that these upward-sloping layers were not formed by calm water, but rather by the deposition of ancient, capping sand dunes. In other words, the solid rock we see today may have been blown by winds billions of years ago, much like the sand dunes of the Sahara Desert. This image offers a glimpse into an ancient Mars, with its howling winds and swirling dust. But exploration is never a smooth journey. Just as Opportunity found a seemingly gentle slope and prepared to descend into the crater's floor, it faced its most daunting test yet. A massive global dust storm had spread across Mars, obscuring the sky and reducing sunlight intensity by 96%. This proved fatal for the rover, which relied on solar panels. Its power plummeted, and at one point, it threatened to run out of power and damage its electronics due to the extreme Martian temperatures. For weeks, the ground team was forced to put the rover into its lowest power sleep mode, attempting to communicate only once every 3 days. It was an agonizing wait. Fortunately, Opportunity survived the storm and reawakened on Sol 1271. After the storm, Opportunity finally made its way to the north slope of the crater. He carefully examined the exposed bedrock, grinding and analyzing it with rock grinding tools, and captured more immersive images of the steep slope. However, the crater floor, covered in sand dunes, proved too treacherous. Based on the data he collected, scientists concluded that the environment here was likely historically too harsh, with extremely dry and acidic soils, to be suitable for life. Thus, the new target lit up a larger Endeavour crater in the distance, where it was suspected that there were clay minerals that marked a liquid water environment. Opportunity once again set foot on a new expedition.